These are our notes on parallelograms. Here's our parallelogram here, and the question is, what do we know about parallelogram ABCD? So I'm going to pause the video now and you go ahead and write what you think you know about that shape if it's a parallelogram. Hopefully you listed these same things. We know that the opposite sides are parallel, which you can see here. We know that the opposite sides are congruent, and here's our congruency marks here. We know that the opposite angles are congruent, so I showed that. Those angles would be congruent, and these angles would be congruent. Consecutive angles would be supplementary, so that would be these two would add up to equal 180, or these two. And the last thing we have is that the diagonals bisect. So if you had your diagonals drawn in here, since they bisect, they would also be congruent. So here's the diagonals bisecting in the green lines here. We can see that this side would be congruent with this side, and this side would be congruent with that side. Here are the characteristics that we're going to focus on today. Opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect. So in this first example problem, we need to solve for x and y, and we can see up here that it tells us opposite angles are congruent, which we know that when we're working with a parallelogram. So that's telling me that this angle is congruent with this angle, and this angle is congruent with this angle. So go ahead and see if you can set those up and solve for your x and y. So when you solved for this, you should have found that 7x plus 2 equals 50. We're going to subtract the 2 from both sides, and you end up with this. Your final answer should be that x equals 6.9. So we could plug 6.9 back in here if we want to figure out what this angle is. And then for the y value, we know that 2y equals 130, so we set that up. Divide both sides by 2, and we end up solving that y equals 65 is what our answer would be for that. Hopefully you found the same thing. For this next example, we want to solve for z. After we solve for z, we also want to find all four angles. So with this one, we're being told that consecutive angles are supplementary. So remember, consecutive angles are angles that share a side. So we've got these two angles, and they definitely share a side. So we want to set that up and solve for our z in this case. That's where we're going to start, and then we can go ahead and solve for the other angles. So I'm going to pause the video now. You go ahead and see if you can set that up to solve for z, and after you find z, plug that z value in to solve for the other angles as well. So how we solve for this is you should have set up the 5z plus 1 plus the other angle is 8z minus 16. We should have set those equal to 180 because they were consecutive angles that were supplementary. And then we just solve for our z, which is what I did here, and you should have found that z equals 15. Once you find your z value, then we can plug it back into our original angles. So we would end up with 76 and 104. We know that these angles are congruent, so this angle would also be 104. And the angle that's congruent with this one, which was 76, would be this bottom angle, which is also 76. So hopefully you found the same thing for your answer. In this example, we can see here that it tells us diagonals bisect each other, so we can see that happening here. And since the diagonals bisect each other, we know that this side must be congruent with this side. So to solve for what the measurement of CD, so we're looking for this line segment CD, so to be able to get that measurement, we're going to have to take this and set it equal to this. So I'm going to pause the video now, and you see if you can solve for x is going to be our first step. And then since we want the measurement of segment CD, after you solve for x, you need to plug that back into these to get what our measurement would be. Go ahead and try that now. When you solve for x, we set those two sides equal to each other, and you should have found that x equals 3. we were looking for the measurement of segment CD, so we then had to plug that 3 back into each of these, and you would get that this side was 30 and this side was also 30 because they are congruent. So our segment CD is equal to 60. Hopefully you found the same answer. In this example, we know that ABCD is a parallelogram. We have all of this given information, and we have to try to solve for the variables x, y, and z. So I can see that I have my x variable here on the diagonals. I've got my y on these parallel sides, and I've got my z value over here, my variable. So we've got to try to solve for that. So I'm going to pause the video, and you can see if you can solve for each of those variables. So when you solve for these, I started out over here with my x variable, and I could see that these two, this diagonal was bisected, so I just set this equal to that, and I found that x equals 3. Then I went on to my y variable, and again I could see that these two parallel sides, which I also know are congruent, so I set these two equal to each other as well, which is what we did up here. And when we solve for that, we find that y equals 7. My last variable, I've got angle ABC. So when I look up at my parallelogram, I can see that angle ABC would be right here. So I'm really focusing on this angle. Just changing back over my pen. So I'm focusing on that angle. And the other angle I have is angle BCD, and I know the value for that. So BCD would be right here. From my parallelogram, I can see that those two angles would be consecutive angles because they share a side. So therefore, I took everything that I had here and added it together and set it equal to 180 because I know that consecutive sides are supplementary. When I did that, I solved for my z and found that z equals 6. And that was the last variable that we had to solve for parallelogram ABCD. Hopefully you found the same answers. Here's our last example problem, and I can see for this one we have parallelogram RSTU, and this is our parallelogram that we're working with. We have to find angles 1, 2, 3, and 4. So I can see here I have angle 1, angle 2, angle 3, and angle 4. Here are my two givens, so I need to use this information to try to solve for these. So I'm going to pause the video now. You see if you can figure out how you would solve for those angles given these two. When you solve for this, hopefully you noticed that we had these alternate interior angles. So we had 33, which would make this angle 1 also 33. On this side, for angle 2, we know up here this angle was 39, so therefore this angle would be congruent, so it would be 39 as well. To figure out angle 3 and 4, we had to add these two angles together so that we could get the full angle here, which 33 plus 39 gives us 72, which is what this angle measurement is here. We can see that these are consecutive angles, so they share a side, just like these share a side. So we know that that should add up to 180. So if you take your 180 minus the 72 that we found here, that would give us our other angle, which would be 3, angle 3, which is congruent to angle 4. So when you find that measurement of 108, That's the measurement for both angle 3 and 4.